This video is going to be about finding the limit as n approaches a point, such as 4, rather than infinity. First, let's look at a slightly different but similar definition of a limit. The value or height a function appears to be approaching. So a limit is a height a function appears to be approaching. So if we look at this graph of f of x, we see that as x approaches infinity, so x goes towards infinity, going all the way to the right, the height of the function is appearing to approach 5. We know it's never going to hit 5, but it appears to approach it. So the limit of f of x as x approaches infinity is 5. So here's our new idea for this video. X does not need to approach infinity. We've only seen cases, such as down here on the left, when x approached negative infinity, or over here on the right as x approached positive infinity. But in fact, x can approach a number, and we can still find that intended height. So for example, we could look at a function as x approaches negative 3, as x approaches 4, as x approaches 0, really any value. So here's a first fairly simple example. You can see here a graph that looks pretty much like a line. Something weird happens right here where there's an open circle and then we have a closed circle down here, and then it continues on to be a line. So I'm asking you to find the limit of this function, which I've called g of x, as x approaches negative 1. So let's remember the definition I said, that the limit is the value or the height the function appears to be approaching. So if I look over to the left at negative 1, I'm looking for the height the function appears to be approaching at negative 1. So if I go up here, well, the function exists right there. So the function appears to be approaching the height it actually reaches. And we can see that the height there is 2. So the limit of g of x as x approaches negative 1 is actually going to be 2. Now you might be thinking to yourself, how is this any different than just finding the value of the function at negative 1? And in this case, it isn't any different. The value of the function at negative 1 is still a positive 2. X negative 1, y positive 2. We will see a difference though, so just wait. Here's another example. This time we're looking to find the limit of this function as x approaches 0. So let's look at 0. Again, at x, I'm going to look up, see where my height is of my function. It's at 3. Again, the function exists there, so the limit is going to be 3. It appears to be approaching 3, and it actually is at 3. Again, not much difference between the limit and the actual value of the function. Our last example with this graph is going to be looking at the limit of g of x as x approaches 1 and comparing that to the function value at 1. So if I now draw in a vertical line down here at 1, the function appears, if I look close to 1 over here on the left and close to 1 on the right, the function appears to be approaching a height of 4. If we couldn't actually see what was happening at exactly 1, at this exact vertical line, every single person on the planet would guess that at 1, the height was 4. That 1, the x value of 1, corresponded to a y value of 4. And here's where we're going to first see a break from the pattern of the limit equaling the function value. If you guys think way back to the piecewise function unit, you would remember that when you see an open circle, it means it's not included in the graph. this dot down here at the y value of 2 is actually the dot that goes with the x value of 1. So if I was plotting this graph, when I got to x equals 1, I would plot the corresponding y value of 2 rather than 4. And here we see the first break of the pattern. Just to re-emphasize, what's important for the limit is not what the actual filled-in circle says, but where we appear to be approaching. The limit is not concerned with the actual value at x equals 1. Let's look at another example. Here we have another graph that sort of looks like a line, and I've called it m of x. It is a function. The first question here, limit of m of x as x approaches 0, is again that case where nothing unusual is happening at x equals 0. If we look, find x is 0, it's right here at the origin, and we go up, because remember we're always looking for the height, to 2, we can see nothing, again, nothing unusual, so our limit is just 2. However, if we look at this other one, limit of m of x as x approaches negative 4, this is where we have another one of those unusual open circle, closed circle situations. At negative 4, the place the graph appears in all other spots to be heading is actually down here at negative 2. That makes the limit equal to negative 2. However, if I had asked you for the value of the function at negative 4, you would have had to say positive 1, because the filled-in circle, which is actually part of the function, is up here at positive 1. Again, the limit doesn't care about the actual value at negative 4. It doesn't care at all that m negative 4 is positive 1. It only is looking at things really close to negative 4 on either side. And you can see that it looks like it's headed to negative 2. Here's one last example before I ask you to do some on your own. Here I have a function that I'm calling h of x this time. It's not a line, but that's okay. And I'm asking you for the limit as x approaches 2. So the first thing to always do is look and see where x is approaching, then go to your graph and find that x value. So here's x is 2. So then I follow up, the dashed line's already actually in for us, follow up, and take a look what's going on with the graph. The filled-in circle is up here at 8. That means the actual value of the function is 8. However, everything really close to 8 makes you think it's actually going to be where this open circle is, which I'm going to approximate and say is about 7. It's not exactly 7, but close enough. So the limit is 7, even though the actual value of the function is 8. Okay, so here's your homework. Use this graph of f of x to find the limit as x approaches 0 and as x approaches 2. A word of caution, x is 0, that's right here, and you're looking for the height. You're not looking for where it crosses the x-axis. That's a very common mistake. Good luck. Happy weekend.